Good morning everyone. In this video I am going to explain about Feynman tricks of integration, which is one of the fascinating tricks in integration. Integration is rich with all the fascinating tricks. One of such tricks is called as Feynman's tricks. Feynman tricks is found in several in Feynman's autobiography. I would like to explain about how the Feynman tricks works in the problems. First, I am going to write one problem. First problem is the integration of 0 to 1, definite integral. Integration of 0 to 1 x to the power 2 alpha minus 1 divided by ln x dx. So here, we should observe clearly that alpha and x are the two variables. Alpha is any real number, x to the power 3 minus 1, like x to the power 3, x to the power 4, like that. We should take alpha as here. Due to the presence of ln x, it is very difficult to integrate, such that we should take this whole integral as I of alpha. So I of alpha is equal to 0 to 1 x to the power 2 alpha minus 1 divided by ln x dx. So the central idea of Feynman tricks, which is differentiate the variable which is other than the variable of an integral. So I dash of alpha becomes d by d alpha of 0 to 1 x to the power 2 alpha minus 1 divided by ln x into dx. Since alpha and x are the independent to each other, I will pull out the variables which are not related to alpha. So this whole integral becomes 0 to 1 d by d alpha of 0 to 1 x to the power 2 alpha minus 1 divided by ln x dx. So the next step is, so we should differentiate the function which is containing alpha as a variable. 0 to 1 by ln x is here, ln x is a constant here, alpha is a variable here. So d by d alpha of x to the power 2 alpha minus 1 into dx. Okay. So d by d since here x is constant and alpha is variable, we know the formula that a power x is equal to a power x into d by dx of d alpha of a power alpha is equal to a power alpha into log a. So it becomes 0 to 1 by ln x into this whole thing becomes x to the power 2 alpha into ln x dx. Should directly write in which the formula is now. So ln x and ln x are cancelled each other. So 2 also the x to the power 2 alpha, here 2 is a constant. So 2 we have been written here. So 0 to 1 ln x and ln x are cancelled each other. So 2 into x to the power 2 alpha into dx. Now we should differentiate, we should integrate the function x with respect to x, since x is a variable here. So dx is a variable here. So 0 to 1. So this becomes x to the power 2 alpha plus 1 divided by 2 alpha plus 1 with the limits 0 to 1. So here when we put the higher value to the integral, it becomes 1 by 2 alpha plus 1. We got alpha as I dash of alpha is 2 alpha plus 1. So our aim is to find out I of alpha, in which we should integrate the I dash of alpha. So integral of I dash of alpha with respect to alpha is d alpha, which is equal to integral of 1 by 2 alpha plus 1 into d alpha. Already it is the form of 1 by x, whereas integral of 1 by x dx is equal to ln x. So this becomes I of alpha. I of alpha is equal to 1 by log of 2 alpha plus 1 into 1 by plus c. So this is not a final value of an integral. So we should find out C in the problem, first problem. So I will rewrite again: 0 to 1 x to the power 2 alpha minus 1 by ln x dx. This we already taken as I of alpha. So applying alpha is 0 here. So I of 0 is equal to, so already we should put alpha is 0. So x to the power 2 into 0 minus 1 divided by ln x into dx. It became, so I of 0 is equal to 0 here. This is the first value that we found out. See, putting alpha is 0 here. Putting alpha is 0 here. So log of 2 into 0 is 0. 0 plus 1 by 2 plus c. So it became log 1. So the value of log 1 is equal to 0. So I of 0 is equal to c directly. So whereas I of 0 is equal to 0 here. So c is equal to 0. So the value becomes the integral of 0 to 1 x to the power 2 alpha minus 1 divided by ln x dx is equal to ln of 2 alpha plus 1 by 2. Presence of ln x in this integral, it should difficult for us to integrate. So we should use the Feynman's tricks to solve this type of integrals. The next problem is integral of 0 to 1 x to the power cos alpha minus 1 divided by ln x dx, which is similar to the first problem. Here the problem given is cos alpha in terms of alpha. So we should also take this integral of the different integral as I of alpha, in which alpha is one of the variable here. So I of alpha is equal to 0 to 1 x to the power cos alpha minus 1 divided by ln x dx. So in this already I have told the idea of Feynman tricks. So we should differentiate the given integral such that I dash of alpha becomes d by d alpha, integral of 0 to 1 d by d alpha of x to the power cos alpha minus 1 divided by ln x into dx. Since alpha and x are the independent variable here, I should take ln x as outside and differentiate the function containing the variable as alpha. So 0 to 1 by ln x 0 to 1 by ln x into d by d alpha of x to the power cos alpha minus 1 into dx. This is the one of the step. So after the differentiating, it becomes 0 to 1 by ln x. So the d by d alpha of x to the power cos alpha minus 1. So already 1 is a constant. Since 1 is a constant, it is d by d alpha of anything constant is equal to 0. So it became x to the power cos alpha into minus sin alpha into d alpha. dx into ln x here. So into ln x. I will write ln x here. So ln x and ln x are cancelled each other. So 0 to 1. So it became x to the power cos alpha into minus sin alpha into dx. So here since sin alpha is a constant, so we are integrating the function with respect to x. So we should take sin alpha as outside. So minus sin alpha into integral of 0 to 1 x to the power cos alpha into dx. Now it is extremely easy to integrate since ln x is not here. It is independent of ln x. So since cos alpha is constant, so we should integrate. The integration of this thing becomes x to the power cos alpha plus 1 divided by cos alpha plus 1. The limits are 0 to 1. So minus sin alpha is equal to 7, which is constant. So the limit after applying the limits, it becomes integral of 0 to 1. So 1 by minus sin alpha divided by cos alpha plus 1 into d alpha. So I dash of alpha is equal to integral of 0 to 1 minus sin alpha divided by cos alpha plus 1 into d alpha. Like we attained the problem in terms of alpha. So taking 1 plus cos alpha as y. So the dy by dx means dy becomes minus sin alpha d alpha, which is already there in the problem. So it became the I dash of alpha. So 0 to 1 dy by y. It becomes. So I already put the values in this problem. So dy by y, integral of 0 to 1 dy by y becomes log y plus c. So the values are limits are 0 to 1. So here y is equal to 1 plus cos alpha. So log of 1 plus cos alpha, the limits are 0 to 1 plus c. Here like putting like if the limit alpha is equal to 0 here, like 1 plus cos 0. Putting alpha is equal to 1, alpha is equal to pi by 2.